lecture, I would like to share a short biography of you to the participants. We have an eminent expert from Meghna, Mr. Avinash Kishore, sir. He has 20 years of experience as a senior leader and currently working as senior manager in inverter engineering at Meghna. Earlier worked with TCS and engaged with JLR project from 2022 to 2023. Previously, he employed as a Revolt Motor from February 2022 to February 2023 as General Manager Electronics Hardware and Embedded SW. Previously, he has the position of Associate Director Hardware while working as Ola Electric Mobility Private Limited. He was in the position of 4 months, 5 months, October 2021 to March 2022. Before this, he was in the position of Function Manager Electrical Hardware while working as Baxter International. He was in this position for 2 years, October 2019 to November 2021. Prior to this, he has the position of Engineering Manager Electrification while working at General Motors Company for 14 months, October 2018 to October 2019. He completed his MTech degree in Power Electronics from Netaji Subhashan Institute of Technology in 2002. He received his BE degree in electrical engineering in 2000 from National Institute of Technology, Patna. Additionally, he had completed his executive general management program from Indian Institute of Management, Bangalore in 2021. With this, I would request our expert, Dr. Mr. Avinash Kishore sir, to enlighten us with his words of wisdom. Sir, please.
Sure. Thank you, ma'am, for my quick introduction. And again, I do apologize for late joining. Sorry for that, and I can extend 10 to 15 minutes additional in case if any questions. So, thank you very much for joining this session, and thanks for my short introduction. And I'll start sharing my presentation now. So let me share my screen. Okay, I hope you see my screen here. Okay, so today I'm going to explain you about electric vehicle as an introduction. I will take you through the journey of electric vehicle. Let's start with electric vehicle. What is electric vehicle history? I'll talk about hybridization. That means when we say is electric vehicle, it start with the conventional vehicle what we use and still we are using, and then how we are transitioning from EV, from IC engine vehicles to electric vehicles, and in between what is hybrid electric vehicle. So I'll just talk about that. And then I'll take you to that electric vehicle architecture, and I'll talk about what are the major components of electric vehicle, and what's the component level, what's the working, what is the function, everything. And in between also I'll talk about major components, that is a motor controller, battery management system, electric motors, and I'll talk about a little bit of transmission in electric vehicle. I'll little bit cover up for the low voltage subsystems for EV. The EV won't complete until unless you understand the charging infrastructure and very interesting V2X connectivity. So in 1.5 hour of session, I will try to cover as much as possible on the electric vehicle point of view, and feel free to ask question in between. I have a fair experience of industry as well as academic and research and the product development. Mostly I have spent significant years in electric vehicle, right beginning from a work of 10 to 12 years in General Motors, and still I'm associated with electric vehicles and automotive domain. Yeah, so feel free to ask question in between. I'm happy to answer, and I can extend sessions for a couple of minutes again, like I said. And with that, let's start. Okay, so we'll start with electric vehicle. You know that we say that electric vehicle is now booming, right? So everywhere we are talking about electric vehicle and go green, but electric vehicle technology is not new. It's more than 100 years old. And when we started the invention of electric vehicle or vehicle to precise, The electric vehicle started invented first, and first electric vehicle, if you see, that was invented by Thomas Parker, that is 1884. And going forward, the revolution started for the electric vehicles and popularity, where major companies are Detroit Electric Car Company, and other company is Ford. So these are the two major electric, or you can say automotive company, who has started building up the electric vehicles to the market, and both are American companies. But the electric vehicle started declining after 1920s till 1990s. A reason of this decline is because of the invention of IC engine vehicles, IC engines, and the IC engines become popular after 1930s and 40s, when a complete revolution of IC engines took place. In terms of the efficiency, the power, and everything everywhere. And the availability of petroleums has widely spread out during 1930s onwards. And that's the reason, if you see that during 1930s or 40s, electric vehicles were completely killed, and IC engines were, taken over the complete automotive and becomes popular, right? Until unless when history revived during 1990s, when invention, or you can say the revolution started, when semiconductor devices has again popularized with the invention of high power semiconductor switches. To be precise, that means invention of IGBTs, and then further it's MOSFETs, and nowadays silicon and silicon carbide based semiconductors, but it is making more a revolution in electric vehicle. Reason is that having precise motor control, efficient way of motor control, that we will talk about in further upcoming slides. So if we talk about history and revival of modernization, so it started again 80s. The General Motors started the first electric vehicle during 1990, and that was, you can say, first EV were kind of popular, that I'm showing the pictures. So one more major drive factor for electric vehicle is the invention of lithium ion batteries, and this is a kind of a very high uh, power density if you compare with the conventional lead acid batteries. So lithium ion batteries proven that due to really high power density, and it can be one of the major factor for, again, revival and modernization, and reinvented the wheel of electric vehicles, right? And that's how now we say that IC engine age is now declining, and electric vehicle age is now again growing up. Okay, so let's start uh, uh, giving some more insights of electric vehicle. The history becomes popular again electric vehicle when Tesla has come into the picture, right? So Tesla has come the electric vehicle, not only simple electric vehicle, it's also, you can say, as a kind of very high power, or say strong EVs, you can say, as a supercars or race cars. So Tesla vehicles becomes a game changer, and because of the first mover of Tesla, the other OEMs has also started doing the same. And that's how, if you see now in the line of Tesla, there are other vehicles has also, in the similar way, with high performance and high power electric vehicles has come into the picture. So some of the major milestone of electric vehicles are, we'll talk about the electric vehicle from GM. GM having multiple brands like Chevrolet. Then we have Honda. Then we have Toyota. Then Tesla, I have already talked about. Then we have Nissan Leaf. Nissan Leaf is one of the major EV milestone. Then we have BMW. We have Chevrolet Bolt. The Chevrolet Bolt, I have worked a little bit on that. And then again Tesla Model 3, then Porsche. Right now, it's important. We'll take you through hybridization. Right, what we are talking about electric vehicle, and then we start with the conventional. So when we're talking about the conventional, right, so it is nothing but IC engine, right? So we say talk about ICE. So IC engine vehicles where source of energy is nothing but petroleum, right? You can say fossil fuel. The source of energy is the fossil fuel. So the petrol or diesel, etc. So the problem here, if you see what I am representing this picture, that emission is high, right? Because of the petroleum. Now, when we are hybridization, we are doing hybridizing. That means we are having the source of energy, not only one, more than one, right? So one's first source of energy is nothing but the IC engine. That means the fossil fuel, right? And then other source of energy is the battery, right? So where we are storing the energy, electrical energy, and we are putting into the electric vehicle, or you can say hybrid electric vehicle, and hence we do hybridization. So with that, what exactly we are achieving? We are achieving little, fuel economy. That means you can say fuel range is improved, and then emissions are decreased, right? So some of the functions of, I would say, uh, automotive or vehicle will be performed by the electric, and some of the performance, for example, driving or accelerating. There are 4 or 5 modes of electric vehicle that I can talk about. Some of the performance were done by IC engine, right? So together it is reduced emission. Now coming to the plug-in hybrid. So what it mean by the hybrid, and what is the difference between plug-in? In If we say hybrid or strong hybrid or full hybrid, if you see, there is no source of charge externally. You can ask the question that how the vehicles are getting charged. So answer for this question is that this battery is getting charged while some of the operation of hybrid electric vehicle. Some of the operation maybe, one of the maybe it's like a region, right? Or maybe cruising. Okay, so there are some opportunity charging happen this electric vehicle, hybrid electric vehicle internally, right? But these opportunities are not so much. Because of that, the battery capacity we cannot put as a high capacity battery, right? So we can extend a little bit of range. But let's say if you are adding the source of battery as an external charging, that means you are providing either onboard charger or offboard charger. That means you can always play with the bigger capacity of battery, bigger capacity of motors and other accessories, and hence the more miles you are getting from electric, and maybe lesser miles you are getting from IC engine operation. And with that, you are actually reducing the emission, right? So it is a plug-in hybrid. Now going to all electric, now we are removing completely the IC engine, and we are only having battery, electric battery, but they charge, because we cannot charge, we cannot charge in external means. Without external means, we cannot charge the battery. So hence, this is the all electric with no emission, right? There is no emission because there is no fossil fuel is used. There is another hybrid electric vehicles. We should always aware that that's called fuel cell. Fuel cell is a specific type of battery which have uh, different chemistry, which takes hydrogen as a separate, and with that it creates, you can say, it is a kind of a battery which have a different chemistry, which is hydrogen. So hydrogen you have to fill it, and hence it becomes a fuel cell. So this again have no emission. So in this case, you can charge the battery, and plus you can fill up hydrogen externally, and you can put the cylinder inside. So fuel cell is not getting popular because of certain other reason. However, there are many other plans for many big OEMs to popularize fuel cell electric vehicle as well. But right now, as a globally, most of the governments of the countries, they are making the policies to boost the electric vehicle, right? So one of the policy is, I'll talk about, if you know about in India, that is called the FAME discount. They are giving some discount. Plus, they're also boosting the ecosystem, right? When we talk about ecosystem, that means you must have, the charging infrastructures. Then you must have the complete uh, dependency or policies which can boost the electric vehicle, right? Okay. So let's move on. In same context, when we are talking about electric vehicle, hybrid electric vehicle. Now, when we're talking hybrid electric vehicle, again, this is depend upon how much hybridization you are going to do. So based upon that, it can be divided into 3 or 4 different categories. Let's start with the conventional vehicles where there is no hybridization, is a completely IC engine. Then we can have a micro hybrid. Micro hybrid, that means you are putting a very small motor and there are certain things only you do, right? So these can be start stop. Then you increase the motor size. That means you are increasing the battery size as well, and you can have little more electrification to the electric vehicle, hybrid vehicles, and it becomes the medium or mild hybrid. When we're talking about full HEV, that means that your vehicle can go completely with HEV, that means electric mode with certain miles, depend upon the battery capacity, and it can switch to the IC engine mode, depend upon, or it can do the hybrid, both, right? In the same way, we are talking about plug-in hybrid that I talked, because in full HEV, we don't have the option to have an external charging methodology. Okay, but in plug-in hybrid, you have to have external charging methodology so that you can charge your vehicles externally. So if you have that facility, you can go for the higher capacity battery, right? And then electric vehicle completely. There is no IC engine, there is no fossil fuel, only source of energy is the electric battery. Okay, so this is four things. Some insights before going forward, I would like to give you. Just a moment. If you have any questions in between, you can just ask the question, because I am not seeing the chat window. Hence, I may not able to see your questions if you are putting it. So you can unmute and interrupt me in between if you have any questions. Okay.
Sir,
So yes, yes.
sir, when it comes to the hybrids, sir,
Yeah.
can we use solar and battery, sir? We can combine
So
the solar and battery.
yes, you can use it. So there are certain some concept cars are there, which they are using the solar batteries. They are putting the solar cells on the rooftop, but
Yes.
that is for a concept basis. It is feasible. It is definitely some people has done it, but it cannot be feasible for a mass people, right? Because
Okay.
if you talk about the solar, you always need sun, right?
Right,
Let's
right,
say
sir. Right.
if there is a cloudy, right? It's clouds,
Okay.
so you do not have the sun are not available. That means you have the problem. Plus, the efficiency will be less because the solar cells you are going to have a big rooftop, and this will not be so much of handy or comfortable, right? So it's not a popular because of not so much of you can say comfort or easy to use. Okay.
In case if you use the solar panel, it is suitable for only a low power vehicle, sir. Or other case, we can use the high power vehicle
No, high
also.
power we cannot use because solar cell efficiency is low. And if you
Uh,
want to go for high power density batteries, solar cell cannot be used because even charging the batteries takes 4 to 5 hours, depend upon the. I can if you talk about the battery, I can keep talking about the battery, but with the solar cell, the battery cannot be charged because of its low efficiency.
sir,
Solar cell is low efficiency. Yeah.
some three-wheeler rickshaws, sir, have
Yeah.
commercialized vehicles have this kind of setup, sir. So can you tell
So
me the any
so that
limitation?
so that what is happening, I'll tell you. So
Okay.
what happened that let's say you have a hybrid, right? So you are doing some IC engine, right? Then you
Okay.
are having some battery, right? So plus you are doing some solar cell, right? Something
Okay.
like that,
Okay.
correct? So
Okay.
you're
No, sir.
having mixed load.
No, no. I not consider the AC, sir. Only battery
So
and the solar panel.
so let's say you consider these two, right? So
Ah, okay.
you can always have these two, and depend upon what capacity. Let's say the external battery, you are taking 80% of the source of energy. Solar cell is a 20%. So depends. You can always do so, right?
Okay.
Okay.
Okay, sir.
Okay. Yeah. So some if you talk about the hybrid electric vehicle, we have already talked about mild, medium, and strong. Then again, depend upon the configuration. You must know there are 3 or 4 type of hybrid electric vehicles, right? So I'll go through that. and it will be interesting, right? So I'll just skip this slide because I have already talked about what is mild hybrid, what is medium hybrid, what is strong hybrid, right? Just I'll just consolidate here. Mild hybrid, you can have 5 to 10% of fuel cell fuel saving. Examples are Maruti Saj in India. With the medium hybrid, you can have a 50 to 20% of fuel saving. With high voltage motors, 158-volt motor. The examples are Honda Civic. With the strong or full hybrid, you have to have a high voltage. If you see, in this case, you are having 220 to 800-volt motor, right? This is quite strong. And in that case, if it is hybrid, you can have almost 50% of fuel saving, right? So your range is multiplied by 2 times, correct? Mind it, this is a hybrid, not a plug-in hybrid, right? The examples are Toyota Prius and Grand Vitara. When we're talking about a plug-in hybrid, let's see if I say full hybrid. Now add here plug-in hybrid, right? Sorry. Add here plug-in, right? When you're adding the plug-in hybrid, what you're doing, you are only adding a kind of charger here, right? Externally, right? That means with the external, you are externally power sources, you are charging the battery. So in that case, you can increase the size of the battery, right? And hence the fuel capacity or saving will be even more. Your range will be even more if you are adding a plug to the battery. What you need to do, you need to add a charger, right? On charger, this is again a two types. One is called the OBC. This is called the onboard charger, and the other is an off-board charger, right? Onboard charger is nothing but you put a charger inside the vehicle, right? Off-board charger, that means the charger it's not part of the vehicle. So charger part I have already covered in my today's talk. In with some pictures I'll talk about. Okay. Any questions here? Okay, so quickly I'll cover series and parallel. Please note it down. You should know what is series hybrid. See, now, see this picture here. I have taken this picture, the series hybrid, what is happening, right? So let's say this is a final drive. This is a final drive, okay? What is happening that the electric motor is driving, right? What is the electric motor? Electric motor, in this case, this is a three-phase permanent magnet synchronous motor. I believe everyone knows what is permanent magnet synchronous motor. So this is driven by electric, and basically this has to be taken the three-phase AC. Okay, how this three-phase AC is coming? This is coming by the controller. This controller is nothing but inside there is a three-phase inverter, right? I'll talk about inverter. If you don't know inverter, inverter is nothing but converting. Inverter, what it does, it take the DC input, okay, and convert it to the AC input, AC output. In this case, it is converting three-phase AC output, okay. Now, if you see the energy storage, this energy storage is nothing but battery, okay. So the DC is going from battery, but again, what the engine is doing. So in series hybrid, the engine is connected, coupled with a generator. This is the AC generator. This AC generator is connected with the inverter. Okay. This inverter is nothing but what it is doing. It is converting AC to DC, and then DC to AC, it is going here. And in between, the battery power is also going to the battery. Battery power is also going to the DC, right? So this is a DC. In case you want to charge the battery, so this engine is itself is charging the battery, right? If needed. So in case this is a strong hybrid, it is getting charged by the engine. Number one. Second step or second way to charge this battery, when you have a regen condition, when you are capturing the regeneration power and you take it from this motor becomes the generator, and with this controller again it is getting charged, right? And then third option will be the of charging the battery will be the cruising, okay. So in the cruising condition also capture some energy and charge the battery. So this is the option of the series hybrid, right? So if you see the series hybrid, how IC engine, then generator, then controller, right? Then electric motor, and then final drive. So this is in series, right? In between battery. Now, the final drive is always electric, right? Final drive is always electric. IC engine is not connected with the final drive, right? But what you do, what you see in the parallel hybrid, I have this picture here. By parallel hybrid,
Sir,
what is happening? Yeah,
sir, in series connection, sir, please
yeah.
move back. So in which generator give power to the both electrical motor and the energy storage simultaneously, sir?
Yes. So this particular controller is nothing but back-to-back converter. So if you know, this is nothing but, I'll tell you how it works. If you know about inverter, I can talk about that as well. So it is like that. So we have, let's say we have a generator, right?
Okay.
The generator is giving a three-phase AC. Okay.
Okay.
So that this three-phase AC is going like this, and then it will be a inverter, three-phase inverter like this. This is inverter one. So how it is connected? Okay. So it is connected like this. Okay. Now this three-phase AC is converted plus minus DC. Okay. This DC is connected to the battery. Okay. Okay. And now there is another inverter. Okay. There is
For
another
electric.
inverter is connected, which is connected to the motor. Okay. This motor. Okay. This battery is this one. This is the battery, and this whole part is nothing but controller, right? So yeah. So what is happening that this whole controller is controlling the power flow. That means when you want battery to discharge and when you want battery to charge. So everything is controlled by this controller, right? So if you see, this controller is having two inverters inside. One inverter is doing AC to DC. This inverter is doing DC to AC. And all power flow is controlled by the controller because these are connected with the IGBTs or semiconductor switches, 6 switches, correct? And finally, it is controlled. So battery charging or discharging, all are controlled. So now the thing is that when you want to charge, when you want to discharge, all algorithm has to write, you have to write it here. You understand? Okay, fine. Now coming to the parallel hybrid. So if you see the parallel hybrid, it is interesting that the final drive, I carefully look here. So this is the final drive, right? This is the final drive. Final drive, the power is coming from the IC engine as well as the motor, right? So yeah, just a moment. Let me finish this talk. So in the parallel hybrid, the power is coming from the IC engine and motor simultaneously. That means you see that power is coming from two sides, how it is split. So there is a gearbox which is actually taking the power and simultaneously it is giving to the final drive, right? And these gear systems are special gears. This is a kind of planetary gear system which is driving the two mechanical they are coupling two mechanical forces into one. Okay, so this motor, this number 2, which I'm telling you as an electric motor, it is connected with the battery. There's an inverter, so DC, AC, and this motor is driven by the battery. In another side IC engine, which is directly coupled with the gear system, right? So mechanical power is coming here. Let's say P mechanical 1, and this is the P mechanical 2, and both are combined through the gearbox and finally connected to the drive. So in case of parallel hybrid, the final drive is combination of both IC engine and battery. You understand? Any questions here?
So your PPT is not visible, sir.
Sorry?
Your PPT is not visible, sir.
Is it everyone is not able to see my PPT? Because I'm sharing already.
No, it's visible, sir.
It's visible, sir.
Okay, okay, fine, fine.
Visible,
I
visible.
think okay, maybe some issues with your system, sir.
Okay, I will
Okay. So I'll move quickly. Can you put your thing on mute because I'm hearing echo. Okay. Can someone go in the mute, please? Because I'm hearing echo. I think this is good. This is good. Okay.
Sir, I have a doubt.
Yes.
In parallel hybrid, both are working. IC engine and motor is working. So how it used to control the power by both of them? Controller is there?
Just a moment. Yeah. Can you put in the someone in mute because I'm hearing echo, please? It is getting disturbed.
Sir, in parallel hybrid,
Uh-huh.
engine and motor both are working together. Is that working together or it is
Yes,
controlled by controller?
it is working together. And can someone go in the mute? I'm hearing echo. So, okay. So what I was telling that both are working simultaneously. This electric motor is controlled by the inverter, and IC engine is controlled by its own controller. Okay. So IC engine is controlled by its own controller. We can say as an engine controller.
Okay, sir. Thank you.
Yeah. Okay. So quickly, I'll just finish. Now you understand we have series and parallel hybrids, right? But now combination of these two also possible, so that you can always take advantage of series or parallel or series or vice versa, right? So merge these two in one, and hence your system becomes series parallel or parallel series, or you can say power split. Okay. Okay, so I'll just now move on. I'm coming to electric vehicle architecture, and I hope you understand, very short glimpse of what is electric vehicle, hybrid electric vehicle, right? So now the actual things started here. High level, what is electric vehicle, right? It's very simple. It is very, very simple if you compare with IC engine. But as an expert, you should know that the function of each and everything. And I'm going to talk about something where it will be really interesting for you. So if you see this particular architecture you have seen somewhere, what exactly is happening? The simple drive, right? It's simple drive where you see a battery. Okay, where you see a battery. Battery is what? It is nothing but a DC, right? Battery is DC, right? This is the battery, and it is having a DC. Why we are putting battery pack? I will come to that. I have a separate slide of that. So these batteries are in the EV. It is high voltage battery. So it start with 48 volt, 72 volt, 105 volt, maybe 200 volt, 400 volt. All are DC, right? 800 volt, and now 1000 volt, right? You see that 400, 800 volt really high, correct? So this is really, really high voltage because we are now doing that really high power or high performance vehicles, correct? So the battery pack, when we say, it is a combination of multiple battery cells, and combined series or parallel, it becomes a battery pack, and finally we are getting the output. Now if you see here, when we say DC voltage, we are representing as a DC, and what will be having the DC plus minus. Let's say we are having a 48 volt system, right? Now directly I will go to the final muscles of the electric vehicle, that is the electrical machine, right? So do you know that all electric vehicles, the electrical machines are AC, and that also not simple AC. This is a three-phase AC, and which is most of the OEMs use is a permanent magnet synchronous motor, right? And permanent magnet synchronous motor are three-phase AC. Now, like I said, to convert a DC to three-phase AC, you need a inverter. Okay. Just a minute. So you need an inverter, right? So inverter is nothing but simple inverter. Inverter is nothing but it consists of 6 switches, right? So let's say I'm talking about, let's say these are the switches: 1, 2, 3, 4, 5, 6. There are 6 switches. Let's say 1, 3, 5, and 4, 6, 2. And how it is connected? That means center tap of each switches, it is giving a one phase like this, right? So this is the DC. The DC, if you draw a graph of the DC, it is a simple straight line, let's say 48 volt. But what voltage you need here? You need a three-phase AC. How it looks like? The AC is like that, okay? Three-phase AC is like that, right? Right? So we say like VA, VB, VC, right? The three-phase AC. So the DC is converted to three-phase AC with the help of an inverter. Inverter contains semiconductor switches, 6 switches like that, and based upon this switching, it is converted from DC to three-phase AC. And we are giving three-phase AC to the AC motors. While converting, we control the frequency and voltage of the inverter to achieve desired speed and the torque. I'll repeat, while converting three-phase DC to three-phase AC, we control voltage. That means the voltage magnitude, how much voltage we need, and also the frequency. What should the frequency of the AC, right? And why we do so? So that our desired speed and torque should be achieved. For example, let's say you are driving an electric vehicle, right? So at the time, let's say EV you are driving, right? So at condition 1, let's say at t is equal to 0, your speed is 0, or you can say omega is the speed is 0, omega 1 is 0, right? So what you need, if you compare with the normal EV or normal vehicles, what you do, you start with gear 1, right? So what exactly you are doing? You are commanding your vehicle that you are now at 0 speed, you achieve at 10 kmph, right? That exactly you are giving the command by pressing the accelerator, right? By pressing the accelerator, you are giving command to the controller that please move the vehicles and achieve the desired speed of, let's say, 10 kilometer per hour, right? At t equal to 2, at t2, right? At t2. So this you are giving. So what you need, you remember that when you are having gear 1, your torque requirement is high, right? That means you need some torque at gear 1, and you also need the speed. That means you have the set point of torque and speed, right? So what exactly you are doing from the IC engine vehicles? You are controlling the IC engine, right? By throttling, by accelerating. That means you are opening up the plug and you are allowing more fuel to burn, and that's how you are getting more torque and speed. What is happening in electric vehicle? Because there is no IC engine, there is no carburetor, there is no fuel it is burning. So how you do it is electric motor to generate that much of torque and speed, right? Because ultimate muscle is electric vehicle, electric motor, right? So ultimately you need to achieve the desired speed and torque by changing the frequency and the voltage. You understand? If you have any question, you can ask me anytime. So these are the two things. Now what are the other things? So inverter, now you understand. Inverter is nothing but DC. It is converted three-phase AC, right? Other part is a DC-DC converter. Let's say you have 48 volt and that low voltage battery is also connected. Let's say it's a 12 volt. So DC-DC converter is converting high voltage, right, to low voltage. The DC-DC converter is also comprised of these switches, semiconductor switches. Now the other part is the charger, right? Charger is nothing but either external or internal. It is taking a three-phase AC or let's say single phase AC at your home, or DC fast charger, but ultimately it has to charge the battery. Okay. Any questions here? If you have any questions, any doubts, please feel free to ask. No? Okay. So quickly, I'll summarize here. So you have a battery charger, you have a battery, you have a controller, you have a motor. So power flow through the battery, through controller to the motor, and also power flows through the DC-DC converter. And then also there is a battery connector that is called the low voltage battery. Okay. And then DC-DC converter gives the power to the low voltage accessory. I'll come to that. What is the low voltage accessory? So when you are giving the throttle to the controller, that means you are telling your controller that I need some speed, I need some torque, and internally it will do their own calculations and it will start doing the voltage and frequency control. In short, it is called V by F control to the three-phase AC motor. Okay, this is in short. Any questions here? No. Okay. So quickly, I'll go through the electric vehicle architecture. Now you know that what is electric vehicle. Now, if we talk about what is electric vehicle architecture, one thing, if you see, there is a three different buses. What are those buses? One is high voltage bus. High voltage bus, that means the high power is flowing through this bus, right? This is number one. Second is that the DC-DC converter, which is converting high voltage, let's say 48 volt, to low voltage, let's say 12 volt, and there is a low voltage bus. This is also connected to the auxiliary battery. This is a 12 volt battery. Purpose of 12 volt battery, in case high voltage battery is getting disconnected or maybe some fault or some service, some of the important minimum accessories has to be switched on all the time, and that is mostly the vehicle control system and sensors. Okay, those are mostly the vehicle control system, that is called VCU, vehicle control unit, plus some sensors has to be switched on all the time, no matter high voltage battery disconnected. Okay, what are the low voltage accessories? This may be mostly it is a 12 volt or 24 volt. It may be headlight, blades, horns, right? CAN is the communication system, immobilizer, lights, blowers, sunroof, power steerings, ABS, vehicle controllers, coolant pumps, airbags, buzzer, displays, battery management system, vehicle parking assistance, etc. Okay, we'll talk about few of the things in our upcoming slides. Any questions here? No? Okay, so let's move to something when we talk about. We talked about the electric vehicle. Now you know that what are the major components of electric vehicle, but now you understand that even electric vehicle also, it is some different layouts. One of the simple layout for the low power electric vehicle is a single motor layout. When we talk about single motor layout, that means it is having a one motor. Okay, it is connected either to the rear wheel or it may connect to the front wheel through the gear train or gearboxes with the differential units, either the rear wheel or front wheel. So with one motor. So now, and when we're talking about one motor, so it is the most simple, very efficient, less energy, cheap, cost efficient, right? And as electric vehicle, all regenerative vehicle control, it is there. But because it is a single motor, definitely power is constraints, performance has a constraint, limitation of having all-wheel driving capability, low torque, etc. So for the low power vehicles, you can go for one motor. But we may need to have high power. That means for high performance vehicle, one motor may not enough because we need some power driving. So in that case, two motor electric vehicle is suggested. In that case, you may have the two motors, motor one, motor two. Okay, one motor can be connected to the differential unit. Another motor can also assist to the first motor, so that this another motor can always assist the first motor, or also can do more, other work, for example, regeneration, etc. Okay. So with this combination of two motors, definitely the performance will be increased, all drive capability may be increased, but at the cost of complexity and the higher cost, with the higher weight and space consideration. Okay. The third part is the distributed. However, this is not so popular. That means each wheel connected with the one motor. Okay. This is a two motor layout. But if you say four motor layout, okay, it's not showing. If you say four motor layout, that means you can connect a wheel here, a motor for to the front wheel as well. This is the part of the four motor. Okay. So most popular is this one. Okay. This is not so popular because of the increased complexity. Four motors connected directly with the wheel. So most popular electric wheel configuration is two motor layout. Okay. Any questions
In
still
single
then?
motor, in single motor
Sorry?
configuration, sir,
Yeah.
gear mechanism, it's required, sir.
Yeah. So gear mechanism is required because I'll just tell you that let's say electric motor, right? So you have electric vehicle or electric motor, right? So electric motor speed is very high, right? It may be 4,000 RPM till maybe 20,000 RPM, right? So what you need to do, you need to convert the electric wheel ratio to the final drive, right? So you need the gear mechanism to convert this high speed into the final drive. Understand? So to do that, you need a gear ratio, which is uh, converting high speed motor to the low speed final drive. So gear is required, right? Gearbox is required. Motor is very high speed, so to control or to uh, to what we say, the gear ratio is depend upon the speed of the motor. So you cannot connect directly without the gear.
So gear mechanism control the torque and speed, sir.
No,
But
gear is
convert.
not controlling anything. This gear is not controlling. It is only translating the electric motor speed, high speed. It is only translating high speed to the final drive. You understand? So this gear is not controlling. This is the electric power. It is controlled by the motor only. So motor speed is only controlling, right? So you can always say that, let's say 10,000 RPM, right? It is translating to, let's say 60 kmph. Okay. So in between there will have the gear ratio. Okay. So that's how. So you control the electric motor speed. Let's say it is changing from 10,000 RPM to, let's say 4,000 RPM. That means your speed is also changing. So there is no control of gear ratio changing. So this gear, you can say transmission. Okay. Transmission control is happening in the IC engines, not in the electric vehicle. So, okay, I don't have. So in IC engines, if you see, don't have. So in the IC engines, let's say here, in the IC engines, we have the transmission, which is controlling the speed as well. For example, in our vehicles, let's say if you're driving normal IC engine vehicles, right? So this speed control is happening in the transmission as well, as a part of different gear ratio arrangement. Understand? So for example, let's say you are driving your vehicle at gear 1, right? So you are accelerating it. It is having certain speed, but you want to go higher speed, then you are changing to gear 2 or gear 3, gear 4. It's a manual gear. But if you go to the automatic gear, you don't have to change the gear. So it's automatically, it will change the gear ratio by different combinations internally with different gear arrangements. Okay. In the electric vehicle, you don't need to have that complex gear system. Okay. Because you control part is from the motors. Is electrical. It's called EPS, electric power steering. So it's a control, or it's not EPS, it's the wrong word. It's called the electric variable train. That means electrically variable powertrain, you can say.
Okay.
So yeah. So to control the speed, you change the speed of the motor. To control the electric vehicle speed, you control the speed of the electric motor with the help of the controller. With the help of this controller. How you do? You do V by F. I'll tell you one example. Everyone knows that. You know, for three-phase AC motor, right? You remember this speed. What is the speed of the three-phase AC motor? Is equal to 120 F by P. You remember?
Yes.
Yeah. So now if I ask you, let's say you have frequency 50 hertz, okay, and your pole is 4. So what you will say? What is the synchronous speed? NS. Simply will say 120 into 50 by 4. You say 1500 RPM, correct?
Yes, sir.
Simple. Now if I say, sir, you increase the frequency. Let's say if I say, I'm increasing the frequency to 100 hertz. What will happen? Your
Automatically speed will
synchronous
increase.
speed will be
Speed will
increased to 3000 hertz.
increase. Yes, sir.
RPM. So simply with the controlling the frequency, you're changing the speed, right? Then how you are controlling the frequency? How you are increasing the frequency? With the help of the inverter,
Correct.
right? Similarly, the torque is the factor of voltage, right? Torque is the factor of voltage. So you change the voltage levels, you control the torque. So everything is controlled by the motor controller, and popularly known as V by F control, right? Just note down the V by F control, or sometimes it's called the FOC. FOC is nothing but a field oriented control. Yeah. So this is the popularly known as FOC, field oriented control. It happens only in the AC motors. Three-phase AC motors. What are the three-phase AC motors? Induction motor, synchronous motor, and now we have the PMSM, permanent magnet synchronous motor. We have another motor. It's called the BLDC motor. We'll talk about that. Okay.
Okay.
Yeah. Okay. So now quickly, as a complete block diagram, you have this, drive controller, power converter, motor, transmission system. We have the auxiliary system with the energy source, with the energy management, that means BMS, right? So what I talked about, I will be talking about the BMS. Now you know what is a controller, you know what is a three-phase inverter, right? Correct? So I'll talk about a battery. So battery management system. Now, how many of you know that what is battery management system and what it does, right? We know that is a battery, right? We know that it's a battery, it is there inside, right? But you know that the battery is not simple. You might have heard so many of incident happen that battery got burned, right? Right. So why the battery is very crucial? Have anyone thought of why battery is very crucial? Why battery is simple? For me, for us as a common person, we use battery in the torch, we use battery in the mobile, we use battery in some small things where we never face any problem. But why it is problematic in the electric vehicle, right? The reason is number one, that the battery is lithium and battery is having a very high energy density, right? Right. So I'll tell you, the battery has how we express the battery in terms of unit. So first thing we say in the kilowatt hour, right? You remember that when you go and buy the battery, or you can go to the electric vehicle, you see that, sir, what is the battery capacity? They'll say, oh, my battery is, let's say, 50 kilowatt hour, right? Right. For scooters, anyone know what is the battery capacity? It is a 2 kilowatt hour. It is a 3 kilowatt hour, right? Ola or Ather have 3 to 4 kilowatt hour, right? But if you go to the electric car, it will start with at least 13 kilowatt hour, 20 or 40 or 50, something like that. That means you can take a 50 kilowatt in 1 hour. Now there is another terminology of the battery. It is called the ampere hour. Ampere hour means that it may be 50 amp hour, it may be 100 amp hour. It means that you can take 100 ampere in 1 hour if battery is full charge. What it means? So you know that in our households, we have a 1 to 5 ampere, and that is quite high, right? In our households. But talk about 50 amp hour or 100 ampere. This is too much of current. It is enough to burn everything. So with that, you can consider, you can imagine that the energy density of the batteries are so high. If you do not properly manage the battery, it may be act as a, bomb. It may blast, it may burn, it may fire, it may be uncontrolled fire everywhere, right? So this is a really risky things. Use the very high density battery. So to control the battery, we need a very strong battery management system. Okay, if you are interested, I can talk more about that. So I'll just talk about. I'll talk. So what you need to do the battery management system? What exactly you really need to do the battery management system? First thing is that it always monitor if it is overcharged or overheat. That is number one. Second is that battery continuously do the I don't know, battery continuously do the cell balancing. Okay, continuously do the cell balancing. These are the two things battery does continuously, right? So that it should not go for overheat or any performance issues. Now, as a technical, two things I would like to tell you about the BMS, where more you can always go through some big literature. But as a technical know-hows, you should know what exactly battery is there. So to understand the battery, you must see this particular chart. Okay. So let me zoom this chart out for you. Okay. Yeah. Sorry. So what you see here in the chart here, that this is charge characteristic of the battery. Okay. This charge characteristic of battery means that battery, if you see this blue line, the battery having a voltage is not constant. Okay. The battery voltage is not constant. What it means that? And why it is not constant and when it is low? Now, if you see this blue line, this one blue line, this charge capacity, nothing but state of charge, SOC. So SOC is 0, that means battery is fully drained. There is no charge inside. If battery SOC is 100%, that means battery is fully charged. Now, if battery SOC is low, you see that voltage levels of the battery is also not constant. So this is one cell, the one cell of the battery. This battery cell is a 4.2 volt at its rated voltage. But we see that when SOC is low, the battery voltage is also lesser than 4 volt. Okay. So now when we charge the battery, we can give the full current. This yellow line is nothing but full current, rated current, till the battery get the almost 70, 80 or 90% of full capacity. After that, we reduce the current drastically till battery goes to the full capacity. What it means that, please listen carefully, this is a very good information. It means that we can do the fast charging only till 80 to 90% of the SOC. 0 to, right? That means, let's say, if you are charging the battery in 1 hour as a fast charging, that means we cannot get the battery 100% charge. We can always get 80 to 90% of fast charging. Okay. What is the reason for that? Reason is that the battery safety. When we keep pushing the high current, it may get overcharged, it may get overheat, and battery apparently may get burned or destroyed. So once the battery is almost charged of 80 to 90%, it has to decrease the charging current and rest of the last of the 10 to 20% charge. It should do very slow charging. Now you can ask, sir, what need to do what I'm doing? I'm just plugging it. Then who is taking care of this, all those complex stuff? This has to be controlled by the battery management system. And when you're doing the charger, is the charger also doing the same? Answer is yes. What if charger is not following this particular rule? So here is the battery management system, which is stopping the charger to give more than this current, so it will disconnect it. So that's how battery is protected. You understand? Okay. One more thing I would like to tell you before moving to the next slide. The battery cell balancing. This terminology is very important. You should understand. Usually, if I'm drawing a battery like this as a battery pack, okay. Now tell me, I'll ask the question. Let's say you have a 4 volt, and when I'm charging it, if this battery is having 3.8 volt, one battery, and another is having a 4 volt, will there be a problem? Is there a problem? Anyone? Yes, there will be problem because this cell will take more current as compared to this. Is a simple calculation. So if this particular cell will take more current, what will happen? That heating may here occur more here, right? So now tell me one question. Let's say you have very complex battery here, right? If one cell get damaged, what will happen? A whole battery get damaged. Whole battery will start not working, right? So it is important that these cells should be balanced. What will do? The battery management system will do. There are two types of cell balancing. What is that? Active cell balancing, and another is a passive cell balancing, right? What it does as a passive cell balancing, it will discharge rest of the cells to match the lowest cell. Now all are of cells same level. Another part, what it does as active cell balancing, what it does internally, it will charge and discharge so that all cells become so the same voltage levels, right? So this is cell balancing is a very important role for the battery management system, what I have explained you, right? Just giving a battery temperature. Usually battery operates between 15 degree to 35 degrees C. Less than 15 degrees C, battery perform the sluggish way. That means performance is decreased because of the electrochemistry. More than 35 degrees C, again it is degraded, and hence battery optimal performance should be between 15 to 35 degrees C, right? And hence the battery life will be affected. And what exactly it is controlled? It is controlled by the battery management system. In case battery is getting overheated, battery management system is doing the derating of the battery. Okay. Any questions about the battery management system? Anyone? Before I move to other slide. No questions? Okay. Okay. So quickly, I have already shown you the motor control, right? The same thing, we have the battery here. We have the 6 switches, T1, T3, T5, T4, T6, T2. AC motor is connected. Now this complete, it is, you can see this type of picture is a kind of closed loop AC motor control, and the same technology is used in electric vehicle. It is absorbed as a sensing the output speed and the currents and voltages with the internal control. Like I said, it is a V by F control, or V by F control, or you can say FOC. This is algorithm. It is written in the software in the controller, and it will generate the reference voltages of desired voltage and frequency, where the PWM modulation techniques, it's called the space vector PWM modulation. So it is giving the pulses. This pulses is used to drive the IGBT switches or any other semiconductor switches to turn on and turn off these high frequency semiconductor switches, and hence output voltage is controlled. Output voltage and frequency is controlled, and the motor is achieving the desired voltage, desired speed, and the torque. And the good thing is that the same inverter can be used as a converter in case of regeneration, right? For example, if we're doing the braking, what is happening that the braking, the energy is captured, and is this motor become a generator, and the instead of taking the voltage or current, it will start generating the current, and the direction will be reversed, correct? And what will happen that the same switches, it will use the diode to power to do the power flow, and this battery, instead of discharging, it will start charging. And again, all power flow has to be controlled by the controller. Any questions here? Any questions? No questions? Okay. Now coming to, let's talk about little bit of electric motor, right? Now I have talked about motors, right? How we decide? I'm talking about only, PMSM. But before going to PMSM, let's see that what are the motors, types of motors are available, right? So globally nowadays, only there are few types. We divide the motors into two types. One when we say DC motor, one is AC motor, right? When you are talking about DC motors, there are self-excited, separately excited, series, shunt, field excited, PM excited. There are different types of DC motors. Now, if talking about AC motors, there is a one is induction motor, synchronous motor, and there are another some motors called doubly silent motor. Induction motor again is the you can say wound rotor or slip ring induction motor. There will be a cage motor, you can say a squirrel cage motor. For synchronous motor again, it is slip ring synchronous motor. PM motor, we have a permanent brushless AC, or you can say PMSM. Then we have a BLDC, right? You heard about this BLDC and PMSM, we'll talk about. Then we have synchronous reluctance motor. Some other special motors are switched reluctance motor, and so on, right? There are various type of motor. But the question is that which motor and we are going to use an electric vehicle and why? Let's understand. Let's see this particular slide, right? When we see that what motor should be the most suitable motors for EV, HEV, or PHEV, right? So if we talk about the DC motor, the good thing about DC motor is it is having a better control. While induction motor is a cost effective and very robust. Synchronous reluctance motor itself is also a very robust motor. But PMSM having a very higher efficiency and higher power density. I should always mention that, PMSM is having a power density, very high power density. Yeah. And then BLDC motors, it is also having a very higher torque density. So now which motor you are going to use? Anyone? So disadvantage, DC motor cannot be used. Why? Because it is having less maintenance plus low power density. While induction motor also having less efficiency with low power density. Synchronous reluctance motor is too noisy. PMSM motor is expensive. Why it is expensive? Because it has used the permanent magnets, and permanent magnets are expensive things. And BLDC motor also expensive. So comparing all those things, only the better choice is PMSM. Only reason is because it's having a really high power density. Right? Like I said, usually the ratings of the motors for two-wheelers, electric vehicle is, let's say, 2 kilowatt, 1 kilowatt, or 3, 4, 5 kilowatt, something. That's all. More than that, you don't need for two-wheelers. But for four-wheeler electric vehicle, you need ratings really high. It may start with a 40 kilowatt. It goes to 100 kilowatt. Right? Now I'll tell you, I'll give you one example. If you want to realize that what is the size of the 40 kilowatt motor if we are using induction motor, I'll just give you one hint. If you see some electric motors during at your home, let's say pump motor or motor for water, or let's say in your villages, if you see the motors, pump motor of a 5 kilowatt or 10 kilowatt, it's a huge, bulky. So I think that if you want to take 50 kilowatt induction motor, you cannot imagine that much bulkiness will be there in the electric vehicle, right? You cannot, it is not possible to use that really heavy induction motors for high power. So only option left with a PMSM, because it is very handy, less in size, with very high power density. But yes, it is expensive. Okay. Any questions here? Okay. So when we talk about the permanent brushless motors or PMSM, you must know that there are different type of PMSM, right? When we're talking about permanent magnets, on the rotor side, we are using a permanent magnet other different ways, right? So there are some 4 configuration I have taken, like surface mounted, surface insert, interior radial, or interior circumferential, right? Because of these permanent magnets, the power density is increased and cost as well. Okay. Just one thing, that PMSM and BLDC both are, as a construction wise, similar, only that stator of PMSM is sinusoidally distributed and BLDC is trapezoidally distributed. That means it's a, you can say, in another word, it is uniformly distributed, and you can say as a salient, the poles are in salient manner in the PLDC, right? So PMSM motors having back EMF as a sinusoidal, while BLDC back EMF as a trapezoidal. Because of that, the torques are very smooth, ripples are very low in PMSM, but BLDC torques are high because of the trapezoidal back EMF. So for BLDC is used in the low power and PMSM is used in the high power. Okay. Any questions here? Till I'll just talk about transmission. Any questions here? No? Okay. Then I'll just skip this particular slide and I'll just talk about this slide. Usually, this is the efficiency curve. Okay. Efficiency of the electric vehicle. Electric vehicle is depend upon the efficiency of the motor. Okay. So while the motors of electric vehicles are not fixed for all, so usually motors are very much customized based upon mostly depend upon the application of the electric vehicle. So all OEMs, they do the characterization and see that what is the efficiency curve of the motor. For example, if you see this efficiency curve of the motor, this motor is having a 90% efficiency when it runs and almost 1500 RPM, and when it generates torque of 150 Newton meter. So if your requirement is that, yeah, your vehicle optimum performance is 1500 RPM of the motor with the torque of 150 Newton meter, that means you should go with the motor. Otherwise, you have to ask the designer to design a motor to fulfill your requirement, right? Okay. So this is for the motor. Any questions where I'll just quickly go through some of the low voltages. However, I can skip this low voltages and I would like to directly go to charging infrastructure. Any questions here? In case if time permits, I'll come to that. But any questions still here? Okay. So because I came late, I will be would like to extend this session for 10 more minutes. I hope everyone is okay. Okay. So when we are talking about chargers, why when we are talking about electric vehicle, it is important to talk about chargers, right? So to understand the chargers, you understand the battery is of very high capacity, right? Let's say I talk about, let's say 10 kilowatt hour, right? Battery. So to charge the battery, you need 10 kilowatt hour of the energy. right? So you cannot, charge the battery with a 10 kilowatt charger just like that, so that you can get the charging in 1 hour. You remember I have talked about the battery management system. You remember the CCCV graph of the battery management system like that. Okay. So depend upon the requirement of the battery configurations, there are different type of charger. One is the onboard charger. When you talk about onboard charger, the chargers are built on the electric vehicle. And what are those chargers? What chargers do? Charger is nothing but taking AC and giving DC. That means internally it is converting AC to DC. Okay. So if the charger are built on the electric on your vehicle, it is called onboard charger. Only what you need, you only need to take the plug and put in your grid. For the low voltages or low power, it is fine. Now, let's say if you have a high power, you need a fast charger, and fast charging capacity only happen with the DC charging, right? That means you are giving directly the DC to the battery. So DCs are not available, DC power is not available in our household, so it has to be installed at some specified charging stations, right? Usually when we talk about the chargers, there are 4 modes: mode 1, mode 2, mode 3, mode 4. Mode 1 is single, there is no bidirectional communication, but mode 2, we can say also smart charger. So bidirectional communication is happening. What it means that, the moment you connect to the charger, the battery, so the battery controller and the BMS controllers, they have communication with each other, and accordingly, if you remember, I talked about CCCV graph. So it communicates the battery to the charger about the battery health, temperature, voltage levels, SOC, and current demand. Right now, if talk about mode 3. Mode 3, it has again definitely control and communication will be there, but it have this special arrangement for that AC sockets for multiple other safety things. For example, some kind of current regulations or surges or any other safety steps. So it will have a special type of connector. Now the last is that when you talk about fast charger where you need a substation which is converting AC to DC, and this is directly connected to the grid. Okay. Let's talk about the rating of these all 3 or 4 types of charger. When we talk about normal AC charging, the charging up to 2.2 to 3.2 kilowatt, and this charger is you can use at your home. But fast AC charging you cannot use at your home because this power is up to 22 kilowatt. For that, you need to have a special arrangement at your home or your parking or somewhere else. Now coming to DC chargers, DC charger again is a level 1, level 2. So level 1 is for the voltage up to 48 and 72, up to 10 to 15 kilowatt. But again, DC you cannot put at your home. It again need a special infrastructure. And level 2 DC chargers where it can go up to 150 kilowatt, it cannot also be installed at your parking. It has to be installed certain places where high voltage is connected directly to the transmission. For example, some special charging stations, somewhere on the highway or some special places. Okay. Quickly, I'll just skip this where I was talking about like how things are connected, what charger internally. I'll just skip this slide. Here, I would like to just talk about, like I said, the charging infras are also have special connectors. Now you know that we have 2 type of charger. One is a single phase charger will have a L1, line 1, line 2, and neutral, right? There are 3 things. While 3-phase charger, what will have L1, L2, L3, and neutral. And the DC charger will have the positive and negative, right? DC charger. And the communication line will have a CP and PP. So now you may have a fast DC charger at one connector and 3-phase AC charger, all are merged in one connector. and that will be a CCS combo 2, right? Let's see first one. If you see this one, let me zoom this so that you can see. If you see, this is line 1 neutral with the protective earth. Type 1, this is 3-phase. L1, L2, L3 neutral, protective earth. CPPP, this is for communication, control pilot and proximity pilot, right? Now if you merge DC charging plus type 2, it will become CCS. That means the same connector will have a DC1, DC2, that means a plus minus, with L1, L2, L3 neutral CPV. That means the same connector we can go for AC, DC, single phase AC, 3-phase AC, or DC. So this is the most popular connector in India as well. Okay. Some of the other connectors is called a GB by T. This is in China. Another connectors are Shadmo and Shaoji in Japan. There is a special connector also called the Tesla connector. Okay. Some pictures if you see of the connectors. If you have any questions, I would like to just quickly showcase about the V2X. This is very, very important to know of you, everyone, right? Till now, any questions? Because this will be my last slide. I'll be talking about the V2X connectivity and V2G, that means vehicle to grid, in very short, and try to give you as information as possible. Any questions still here? I'll take maybe 5 more minutes because I was late. So I'll take 5 more minutes. No? Okay. So one thing is important to know for everyone for the V2X, right? Because right now vehicle is not only used for movement purpose. There are much more things we are using with the vehicle, and that's the reason that connectivity becomes very important. When we are doing connectivity important, it is called the V for vehicle cross X. That means vehicle to infrastructure. Let's say that means your vehicle is talking with the infrastructure. Let's say local cellular base, internet, etc., etc. So you get to know. So it is as simple the way your mobile is connected. Then your vehicle is also connected to the network. Vehicle is connected to the battery vehicle. That means your vehicle and other vehicle can communicate, transfer the information. Then vehicle to pedestrian, then vehicle to devices. For example, mobiles and your gadgets are connected. The important is a vehicle to grid, where I want to emphasize little more on that. What is vehicle to grid? Anyone knows? Anyone have idea? What is vehicle to grid? When I'm talking vehicle to grid, what it means? It means that let's say you have a grid here, right? What is happening that from grid power you are taking to the house, and from house you are taking the charger and you are charging your vehicle. What if I say that vehicle is again feeding back the power through the arrangement to the grid? That means vehicle is feeding back the power to the grid. Is it surprising to you? Or anyone have idea, or many of you might have known this, but do you know why we are doing? You may ask the question that why we are doing so, why and how we are going to supply back to the charge to the grid, why we will do, how we will do, and what is the purpose, right? So I'll ask you one question.
To adjust the peak load during
Sorry?
peak hours. During peak hours, if any adjustment is required in loads, so to fulfill the requirement in peak hours, we are going for this.
Yes, you are have one point. Definitely you have put one point. Let me put as a all overview. Now I'll ask the question from you that even why you do so. Sir has said that to fulfill peak requirement. Yes, this is one of the costs. But why you will do so? Why you are really worried about why you are going to damage your vehicle? Do that, right? So there is one thing. It is called the smart grid concept. However, it is partially implemented in India, right? But not everywhere. What is smart grid concept? That means that as a, like sir said, of the peak load, that's a daytime, the loads peak load is high, and the night time peak capacity is low, right? Low peak. Okay, so many of the cities in western countries, what they say that see, going forward, when the electric vehicle loads are increasing, in that ratio your grids are not increasing, right? So how to balance it? One of the ways that you can do the smart grid way, that means that when you in the daytime when you charge, I'll charge with higher rate. For example, in daytime your electricity bill will be more. For example, I just give a one rate. Let's say in the daytime I say, okay, your electricity bill I will charge will be 20 rupees per unit. And if you use in the night time my electricity, I'll charge you only 10 rupees per unit, right? So if your government will give this facility, what you will do? Let's say you don't have electric vehicle, but still you say, boss, I have to run my washing machine, right? Let's do it in the night time. I will save few rupees. Let's say I have to do some, let's say something, let's say electric vehicle charging, right? Let's do in the night time. I will have to pay less amount to the government, right? So this is one thing you say. Now, but if government say, ki boss, I'll give you another opportunity. You charge 10 rupees per unit, and I'll give you option, you can resell to me with 20 rupees per unit. They'll say, boss, now I'm going to earn money because my electric vehicle will be my source of another. Night time I will charge my battery with a 10 rupees per unit, and daytime I will sell back to the grid with 20 rupees per unit. I'm making money. Then you say, what is the advantage to the government? Yes, the advantage is the peak load balancing, like one of sir said, because grid is not increasing the way electric vehicle is increasing. Making grid or making some kind of power plant, it is like a 10 years, 20 years job. It's not like 1 year, 2 year, right? It is a big investment and infra, all those things. So it is even beneficial for the government. Even they are paying you money, it is still the government in the profit. It doesn't happen in India because Indians are, like I said, there are little smart grid concepts are there where in some of the cities they say your bills will be less reduced for the solar cells and all those things. I think some of the states are giving you option, but they said ki your bills can be reduced to zero, but I'm not going to pay. So you're not actually getting money back, but at least your overall electricity bills are getting reduced if you are installing some solar cells. It is implemented in some of the states in India. I know that it is in Maharashtra and maybe some of the states, but I did not hear that you are getting incentive back from the government. Anyway, so this is the biggest advantage, right? To do that. So that this is called the vehicle to grid. To do so, it is not simple. Your charger should be bidirectional. That's number one. Also, you should also have some kind of metering. That means how much you are giving back, how much you are taking from your vehicle. It should be properly monitored. So the smart metering unit also has to be installed, right? And the grid is not a simple, it's not a simple bulb, right? So that you are just put the power. You need some special arrangement to feed power to the grid. Grid is really, really dangerous, right? So all those arrangements are part of the smart grid. It comes with the additional infrastructure, additional cost, but as a long run, it is very important. And many of the cities in Western countries, they have created their cities as a smart grid cities, where grids are bidirectional. You can buy the power from the grid and you can sell power to the grid. It is absolutely allowed. So V2G is very, very important, becoming a part of the electric vehicle revolution. Okay. Yeah. So this is my last slide. I hope you got good knowledge today. I tried covering many topics. Yeah. Future trends, definitely autonomous vehicles are going on. Future is electric for sure. there is no option that we can escape from electric vehicle in India itself. Now battery cells are getting manufactured. Few of the companies have already started manufacturing. In India also, big chunk of lithium ion mines has been discovered. I think it is in Jammu Kashmir and some part of Rajasthan and India. These mines, these particular lithium ion mines is now becoming, now it's a new gold actually. We say it's a new gold, right? So that's all from my side. Any questions I can take, and because I took I actually came 10 minutes late, again I do apologize. Please ask questions if you have, and I'm happy to answer.
Hello, dear
Yes,
participants, please.
I think Dr. Parul has raised the hand. Please go ahead, Dr. Parul.
No question.
Okay.
Sir, one doubt I am having.
Yes, sir.
Sir, in case suppose the two-wheelers are having some charges, so each company will have their own different charges.
Okay. So this is again this is $1 million question. Basically, this is a kind of monopoly. You can say the charging. If you remember, I have talked about the communication, right? So what
Yes.
this company has done are doing the practice that all chargers they are locking with their vehicle. That means they are putting some kind of locking mechanism where BMS will be allowing charging until unless it identify that this charger is provided by my company, right? Hence, even you are going for the same rating of charger, the other chargers won't work with the vehicle. And this is a big setback. That means, let's say if your charger is spoiled, you have to go to the company itself to replace it or repair it. The government of India also coming to the standard regulation that this charging business should be outsourced. That means all vehicles should allow to charge their vehicles and battery with a third party charger so that you can go and buy the charger from the external, the way we do for mobiles. So it is not allowed right now because of the OEMs. That means electric vehicle companies. They are not allowing it.
Sir, in addition to this, I can ask one more thing.
Yes.
Suppose if I want to like start enterprise as a charging station, then the charging output volt should be 230 volt AC. That is enough for two-wheelers?
No, no,
Or
no, 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 no. It is not like that.
uh,
Absolutely not. I'll share because this is a important question. I can I'll share my screen one more time, and why it is not sharing. Okay, so if you see, I have shown you one electric vehicle architecture, right? Uh, Here. So you see that high voltage batteries are different types, 48, 72 up to 800 volt, right? So even batteries are not standard. So if you say 230 volt output, output is not 230 volt. Your input is 230 volt AC. Output is always DC,
okay,
correct?
for the charger output is yes, for charger output is DC. Okay, fine.
Yeah. And one more thing, the charger also it's a 3 or 4 types. Let's say if I come here, yeah, here, yeah. So see, there are chargers. If it is a slow charger, normal charger, the input is normal AC charging, right? So in normal AC charging, input is AC. Input is AC, that means a 230 volt. Okay.
Okay,
In this case, input is 230 volt AC. This is at home. Okay.
okay,
Yeah.
okay,
So these chargers is supplied by the company. So this is also 230 volt. Let's say this is a charger, it is supplied by the company, right?
okay,
Similarly, this is also. So now this particular thing is a charging stations. So most of the companies are creating this type of charging stations, right?
okay,
It's
okay,
not a
sir.
charger, it's a charging stations. So in this case, if you see, there is a charger inside, right? So it may be AC, it may be going AC here, it may be going DC here. So right now it is not clear here, right? And third part is the DC fast charging. It is a huge investment here where you are converting AC to DC, and with the connector, the DC is going here.
Okay.
Okay, so for charging infrastructure, usually what people are doing, doing mostly for two-wheeler, they are doing for this type, you can say this type of thing, or this type of, or this type. But every time the chargers has to be supplied by the charging companies. Only infrastructure will be providing the source of charging. That means they are providing the plug points,
Okay.
right? They are providing the plug point with these available this type of connectors, right? For example, let's say these are the charging infrastructure. These connectors are there because your connector, you want this type of facility, right? Let's say this is a gun, right? So you need this gun to charge your vehicle, and this gun will be available at the charging stations, right? So at the charging stations, you are making the arrangement for this complete power with this charging gun. This is a charging that you are doing. And now I'll tell you again, when you are doing that, you are going to put the rating that this is the, let's say this is a 3.3 kilowatt charger, right? And now if this car is allowing 3.3 kilowatt, then only this car will come to you. Because they say, oh, 3.3 kilowatt won't help for me, they will try to find the fast charger, they will go to that charging station. So in the charging stations, there are multiple levels of charging. I'll tell you, if I have, okay, I don't have. So charging stations, they are putting that, let's say this is, right? This type of connector. They say, okay, boss, my charging stations are having up to 500 volt, right? It can take single phase or three phase. It can go for up to 70 ampere. And with three phase, so this specification is specified. So if car is fine with this, then they will come to you. Sometimes it happens that you are only having a three phase charging, and the car will come and say, I need AC charging single phase. They say, then I cannot provide you, right? Sometimes
Okay.
the car will come, I want DC charging. You said, I am only allowing AC charging, so I cannot help you, right? So there are 3 or 4 types of charging, and then the charging stations, they provide all 3 or 4 types.
Okay. Okay, sir. Thank you, sir. Thank you.
Thank you, sir. I think while transferring from vehicle to grid, are there any parameters that will affect? Yeah, of course, there will be. When you are connected to the grid, there are so many parameters, frequency and the voltage levels, all those things. So the converter has to be take care of this, right? Because the grids are AC grids, right? So if there will be frequency synchronization is needed. So there's grid tie inverter needed. So in one line, I say grid tie inverter needed to do that. So I'm just putting my LinkedIn, note. If you want to connect with me, you can connect. This is my profile. Yeah. Any more questions?
Okay, sir. I have a small question.
Yeah. Yes, ma'am.
Okay. So it is a very nice presentation, and
Thank you very much,
I've
ma'am.
enjoyed. And I'm just want to asking you that is there any future for wireless charging system?
Yes. Of course.
Because
So wireless
uh,
charging system is important, and in US and Europe, they are already implemented
okay,
the wireless
for
charging system.
four-wheelers, for
For
four-wheelers.
four-wheelers, of course.
Okay.
The charging stations for wireless, that means it will be sending coil and receiving coil. So
Uh,
receiving coil should be on the electric vehicle, and the
uh,
sending coil should be at
transmitter.
charging station.
That's
So
charging stations.
yeah, in India it is not there, but in Europe and American countries they are doing that. Few vehicles are already have installed these wireless charging chargers, but again it comes with the cost, man. because
Yeah,
in India, if you
it
put
should be very costly.
everything, that will be costly, and people won't buy. It will be only specific or premium customers who will buy. Electric vehicle itself is a costly, right?
Yeah.
So the OEMs are
Till
trying
now,
to,
it is very costly,
yeah,
and
yeah. So
probably.
OEMs are trying to, cut down the cost. The reason is that battery
Mm,
battery cells are not manufactured in India,
yes.
and battery packs are taking 60 to 70% of overall cost of the vehicle. For example, let's say if you are buying, let's say, I think we have electric vehicle in India, what's called a Tata. Uh, you remember that which vehicle? I think
Tata Nixon.
Tata Nexon, yeah.
Yeah.
So if it is a 15 lakhs of car, so the cost of battery will be itself 8 to 9 lakhs, right?
Yes.
Reason of the battery is very costly because battery cells are all imported. None of the battery cells are manufactured in India. So there are few dependency of the few countries and few companies only. So if you know that India has found a really big mines for the lithium ion, one is near Rajasthan, one is near Jammu Kashmir in
Jammu
their
Kashmir.
hills,
Yes.
yeah. But and some of the countries, some of the companies they have already creating a setup to start manufacturing the battery cells. For example, Ola, Hyundai, uh, Reliance, Rajesh Exports. I think mm, these are part of the PLI scheme, product linkage scheme from the government, having 18,000 crores. So many of the OEMs are claiming that they will start manufacturing the battery cells maybe end of the 2025 or 26. So once it will start happening, the dependency of the battery cells from the outside India, it will be reduced, and the battery packs cost will be reduced, and hence the cost of the electric vehicle will come down.
Okay. Thank you, sir.
Sir,
Yes, ma'am.
sir, if in nowadays EVs are getting more popular, but in future we have to face many problems like battery, uh,
Scrapping, right? Battery scrap or
yeah,
something, right?
battery scrap, and we are taking for battery lithium and all from our earth.
Yes, yes, yes. Yeah,
So
yeah, of course, of course. This is a, bigger problem, upcoming problem. So battery scrap policies, because let's say battery nowadays, electric vehicles are there after 5 years or 7 years when batteries are dead. So people start throwing out the batteries, and these are chemically, too much of, you can say, waste chemicals will be accumulated in the country, and that will be again a bigger problem. So yes, this is, you are right, this is the pros and cons, of course. And yeah, so some measurement has to be taken, obviously.
so for going for an IC engine, there is also disadvantage for that. So which is more reliable? We can go
So
with.
I'll tell you that, if you compare with the IC engine versus electric vehicle, even electric vehicle, you say there is a completely battery operated, or there is no emissions, but actually all battery charging are happening through grid only, right? So somewhere when you're charging at home, some grid is connected, maybe thermal power plant or maybe nuclear power plant or hydroelectric. So it is ultimately going to the grid only, right? So only the
Yes.
only the good thing is happening will happen, that the pollutions what is happening, you're polluting or putting the toxic whole everywhere, that will be reduced, or you can say completely gone. Many of the countries of India, it is having a very much toxic environment because of the high number of vehicles, IC engine vehicles. That will be the biggest advantage. Apart from that, some of the things will be always pros and cons.
Okay, sir. Okay, sir. Thank you.
Okay, so thank you very much. If you don't have any questions, we can close the session here. And thanks you very much for your active listening. Uh,
Okay.
yeah, we had a really, really good questions has come up. And thank you very much for your patience. And sorry
Thank
again
you,
for
sir.
late.
Thank you for your long interactive session. So today we are concluding.
Thank you so
Tomorrow
much.
again we will meet. Good
Yes,
night, sir.
thank you. Good night. Good night,
Good
everyone.
night, all the participants. Okay, we are concluding.
Good night, sir.